This lecture video is about decay factors, and so the last video was about growth factors. And so for growth factors, you're taking some original amount, and that amount is increasing, while with decay factors, the amount is decreasing or going down every time. And so we're going to look at what happens here. So one example of this is something's on sale, and we want to determine the discounted price of a pair of sunglasses that were originally selling for $25 and they've been marked down $40. So when something is 40% off, we take 40% of the original amount, and that's our discount. So to find 40% of 25, we would take the $25 and multiply it by 0.40. And that will give us the discount. So 25, times 0.4 gives us 10. And so this is our discount. So that's the amount that's going to be taken off. And so that would be 25 minus 10, or $15. If a quantity decreases by 20%, how does its new value compare to its original value? That is, what is the ratio of the new value to its original value? Complete the rows in the following table. The first row has been done for us. Notice that the new values are less than the original values, so the ratios of the new values to the original values will be less than 1. Our original values are 20, 50, and 100. We want to fill in our new value column, which means we want to decrease these values by 20%. And so I'm going to take 20 and multiply that by 0.2. This will give me the discount. So I want to discount the $20 by $4. So that would give me a new value of 16. So we want the ratio of new to original, so that would be the new on top and the original on the bottom. So that would be 16/20. 4 divides both of those. 4 goes into 16 4 times and into 20 5 times, and so that fraction reduced is 4/5. In decimal form, 4 divided by 5 gives us 0.8. And if we convert that percent to that decimal to a percent, we would move our decimal point 2 positions to the right. So that would be 1, 2. We need to add on a 0 at the end, and it gives us 80%. Okay. So now do the same thing for 50. So here we had to take 20 times 0.2. And this gives us the $4 that we take off. So to calculate the amount we need to take off of the 50, we do the same thing. 50 times 0.2 for 20%, and we get 10. And again, this is how we calculate this $10. And so the new value to the original would be 40 over 50, which again reduces down to 4/5. And so as a decimal, it's going to be 0.8, and that decimal converted to a percent is 80%. Do the same thing to 100. 100 times 0.2. And we get 20. So that gives us a new value of 80, and so our ratio this time is going to be 80 divided by 100. Divide both of those by 20, and again it reduces down to 4/5. The decimal 0.8, and that converts to 80%. You can pick whatever number you wanted. I chose 200 just because it's a different number and bigger, but it's also an easy number, but you can pick whatever number you want. And so again, to calculate the discount, we take 200 times 0.2. And we get 40, so 200 minus 40 gives us 160. And when we do 160 divided by 200, then these end zeros can cancel off, and we're back to this 16 over 20 fraction, which means it reduces down to 4/5, just like all the others. Decimal representation of that is 0.8, and that means 80%. Use the results from the preceding table to answer the question, what is the ratio of the new value to the original value of any quantity decreased by 20%? Express this ratio in reduced fraction form, decimal form, and percent. And so all of these ended up giving us 80%, 0.8, and the 4/5, even the one that we chose on our own. And so any value that's being decreased by 20% will have this ratio of the new value to the original value. And so as a fraction, it's 4/5. As a decimal, it's 0.8. And as a percent, it's 80%. For a specified percent decrease, no matter what the original value may be, the ratio of the new value to the original value is always the same. This ratio of the new value to the original value is called the decay factor associated with a specific percent. This should be decrease, sorry. So that's called a decay factor. And so notice when something decreased by 20%, then the decay factor was 80%. And so there's a relationship between the 20% and the 80%, and that is that they add up to 100. And so to go from the decrease to the decay factor, you would simply subtract the percent decrease to get the decay factor there. Note that a percent decrease describes the percent that has been removed, such as the discount taken off the original price, but the corresponding decay factor always represents the percent remaining. So when we did the sale example, then the part that you pay for is the 60% if something's 40% off, or if something's 20% off, you're paying for the 80%, and so you're paying for 80% of whatever the item was originally priced at. And so that's why you do this 100 minus 20 thing, because you're paying for the 80%, or in the 40% off example, that you were paying for the 60%. Okay, so the decay factor always represents the percent remaining, the portion that you still must pay. Therefore, a decay factor is formed by subtracting a specific percent decrease from 100, what we said earlier, and then changing this percent into its decimal form. So again, decay factors are represented with the decimal, and so really this decay factor would be represented as in the decimal form of 0.8. Determine the decay factor for any quantity decreased by the following percents. So if something is decreased by 30%, then the amount remaining would be 70%, and the associated decay factor then would be 0.7. Decreased by 75%, then the remaining would be 25%. This one was 70%. Then move the decimal 2 positions to the left would give you a decay factor of 0.25. 15%, the amount remaining would be 85%. And move the decimal 2 positions to the left gives you a decay factor of 0.85. And the last one, 7.5%. So I don't want to do that subtraction in my head this time. So 100 minus 7.5 gives me 92.5%. Move the decimal 2 positions to the left and it would be 0.925. So this next one, explain why every decay factor will have a decimal format that's less than 1. So when you're forming this decay factor, you're subtracting the decrease from the 100%. So you subtract the decrease from 100%, which is equal to 1. And so the decay factor is always going to be less than 1. So the other thing about the decay factor too is that this is just the remaining, so you're taking part off of the original amount, and so then that's another explanation of why this is always going to be less than 1. When we did growth factors, those are greater than 1 because you need the whole original amount, that's the 1 part of it, and then you also need the amount that you're increasing. So when a quantity decreases by a specified percent, its new value can be obtained by multiplying the original value by the corresponding decay factor. That is, the original value times the decay factor equals the new value. Use decay factor for 0.8 to determine the new value of a stock portfolio that lost 20% of its original $40 or $400. So its original amount was $400, and we're using the decay factor of 0.8. And so this is showing that there was a 20% loss. So we take the 400 and multiply by 0.8, and we end up with 320. When a quantity has already decreased by a specified percent, its original is obtained by dividing the new value by the corresponding growth factor. Oops. This should be decay factor. So the new value divided by the decay factor is the original value, and they just got that formula by dividing both sides of this equation right here by the decay factor, and then you would end up with the original value. So again, just like with the growth factors, I tend to just like to plug things into this and then solve for what I need to figure out. I think memorizing less is better, but if you want to memorize both formulas, that's a fine way to do it as well. And the next problem here, you purchase a 2-line answering machine and telephone on sale for $150. The discount was $40. What was the original price? So again, you can go ahead and use this formula if you prefer to. And so the new value divided by the decay factor would be the original value. And so this was discounted 40%, so the decay factor we would have to calculate, and that would be 100 minus 40, which gives us 60, and this is a percent, remember, so now I need to convert that to a decimal, and that's the same as 0.6. So we would take the 150 and divide that by the decay factor, 0.6. And so we get $250 was the original price of this answering machine and telephone. Again, you could set this up the other way if you prefer. And so the way that we would calculate the decrease would be to take the original amount, which is what we're trying to figure out, and so that would be some variable x. So here it would be our original price, and you take that original price and you multiply it by the decay factor, which is 0.6. And that would give you the discounted price of $150. And then to solve this equation, then you would divide both sides by 0.6. And that would give you x. And so that's exactly how we calculate it in the first place. So you can do either method. You do whichever one is most comfortable for you. Determine the original price of a Nordic Track treadmill that is on sale for $1,140. Assume that the store has reduced all merchandise by 25%. So we have a 25% discount. So first we need to figure out our decay factor, and that would be 100 minus 25. That gives us 75, so this is a percent. We want the decimal representation of that, and that would be 0.75. So again, you can use the formula from above if you'd like. That would be 1,140 divided by 0.75. And that gives us 1,520. So the original price was $1,520. Or again, you could say x was equal to your original price. And then multiply that by your decay factor. 0.75 times x would give you sale price of $11.40. And then the way that you would solve this is divide both sides by 0.75. And that's exactly what we did up above, so we would still get the 1,520. And that is the end of the lecture on decay factors. Let me know if you have any questions. Thanks.